Hi friends, welcome to my YouTube channel. This is first part of lecture number 24, and in this lecture we are going to study circuit and waveforms of one phase half wave controlled rectifier with RLE load. So this is the circuit diagram of rectifier. Here load is RLE type, where R is resistance, L is inductance, E is DCMF E. This output voltage we get across this RLE load, and this load is connected in series with this thyristor, and this whole circuit is supplied with sinusoidal voltage source Vs. Vs is equals to Vm sin omega t, and this is the waveform of source voltage Vs. This red dotted line is the waveform of EMF E. Now here in this waveform we can see that this source voltage waveform and EMF E waveform intersect at point theta. So at point theta we can write EMF E is equals to source voltage, and source voltage at this point theta is equals to Vm sin theta. That's why we can write E is equals to Vm sin theta. From this equation we can get the value of theta, and theta is equals to sine inverse E by Vm. Now, one more important thing you must know is that before angle theta, we can clearly see that EMF E is greater than the source voltage. Suppose this thyristor is off, okay, then we can write thyristor voltage Vt as Vs minus E, okay. So thyristor voltage Vt is equals to Vs minus E, and from 0 to theta this EMF E is greater than source voltage Vs. That's why we get Vs less than E. So Vt will be equals to negative because source voltage is less than EMF E. So we can say that thyristor is reverse bias, or we can say that anode to cathode voltage of thyristor is negative from 0 to theta. So if we fire the thyristor from 0 to theta, then it will not get turned on because it is reverse bias. So that's why we cannot fire thyristor from 0 to theta. That's why firing angle of thyristor is greater than theta. Now we will understand the operation of this circuit from 0 to theta. From 0 to theta, thyristor voltage is given by Vs minus E. We are getting this by applying KVL in this loop. Okay. So thyristor voltage is Vs minus E, and we know that from 0 to theta Vs is less than E. Okay, because waveform of EMF E lies over this source voltage waveform. That's why we get Vs is less than E. That's why thyristor is reverse bias at act as open circuit in reverse blocking mode. So when thyristor act as open circuit, then what happens? Then we get no current in the loop, or we can say that output current I0 is equals to 0. When output current I0 is equals to 0, then drop across this inductance and resistance is equals to 0. That's why we get output voltage V0, that is equals to EMF E. Okay, now what is output power P0? P0 is simply equals to V0 into I0. We know that I0 is equals to 0. That's why we get power output that is equals to 0. Now we will see the operation from theta to alpha. Here from theta to alpha we can clearly see that the source voltage is greater than EMF E. Okay, because waveform of source voltage lies over this EMF E. But thyristor is not triggered yet, or gate current is still not applied to the gate terminal of thyristor. So that's why thyristor is in forward blocking mode, and in forward blocking mode thyristor acts as open circuit. So from theta to alpha also thyristor will continue to act as open circuit. When thyristor is open circuit, I0 is equals to 0. What is output voltage V0? V0 is equals to EMF E, because drop across L and R is 0. That's why V0 is equals to EMF E. And what is voltage drop across thyristor? That is simply given by applying KVL in this loop. So Vt is equals to Vs minus E, and output power P0 is equals to 0 because I0 is equals to 0. Now see the operation of this thyristor from alpha to pi minus theta. So at omega t is equals to alpha, thyristor is fired. And we know that from alpha to pi minus theta, the anode to cathode voltage of thyristor is greater than 0. Why it is greater than 0? Because during this period we know that the waveform of source voltage lies over this EMF E. That's why Vt, that is equals to Vs minus E, we get positive. So thyristor is forward bias and thyristor is triggered. So both the conditions required to turn on the thyristor are satisfied, that is VAK is greater than 0 and Ig also greater than 0. So that's why thyristor gets turned on and goes into forward conducting mode, and thyristor acts as short circuit during forward conducting mode. So thyristor during this period act as short circuit. Okay, when thyristor acts as short circuit, then the source voltage Vs will appear across this output V0. So we can say that V0 is equals to Vs, that is equals to Vm sin omega t. And when thyristor is turned on, then we get drop across thyristor is equals to 0. Okay, and what is output power P0? P0 is simply equals to V0 into I0, and that is equals to, because V0 is greater than 0, I0 is greater than 0, we get P0 is greater than 0. Now one more important point, what is current I0? Here in this waveform, inductor is connected in load circuit. Whenever there is inductor in load circuit, then we get current up to beta. Okay, now what is exact equation of current? So when thyristor is conducting, then we apply KVL in this loop. We get Vm sin omega t is equals to I naught R plus L di naught by dt plus E. Here this output current I naught has three components. First is steady state component 1, second is steady state component 2, and third is transient component IT. So for IT, what we have to do, we simply put LHS of this equation equals to 0. So when we put LHS equals to 0, then we get and replace I naught by IT, we get ITR plus LdIT by dt is equals to 0. On solving this, we get IT is equals to A e to the power minus RT by L. Now calculation of steady state current 1. So here steady state current is calculated for this Vm sin omega t. Okay, so that is equals to Vm by Z sin omega t minus phi. This is concept of steady state analysis, that is portion which is covered in network theory. So okay, now what is steady state component 2? This steady state component 2 is due to this EMF E. So it is simply equals to minus E by R. So adding all these three components, we get I naught is equals to Vm by Z sin omega t minus pi plus A e to the power minus R t by L minus E by R. So this is the equation of current we get. But from exam point of view, this derivation is not important. I am telling you for your enhancement of your knowledge. From exam point of view, you need to remember only one point, that is when inductor is present in circuit and circuit is control rectifier, then we get current from alpha to beta. Okay, so here we can clearly see that in this waveform I naught is greater than 0, Vt is equals to 0, and this V naught is also greater than 0. So this from alpha to pi minus theta, this V naught is following this source voltage. So this source voltage appear across output. Now here one more important I want to tell you, whenever there is inductor in the circuit, then diode will this thyristor will conduct up to beta, and this thyristor will remain turn on till we get the positive current, and here we get positive current up to beta. That's why this thyristor will remain turn on up to beta. Okay, so after knowing this much concept, we move to next angular slot. So that is from pi minus theta to beta. From pi minus theta to beta, we can clearly see that this Vs becomes less than EMF E. So voltage across thyristor, that is anode to cathode voltage, becomes negative. Okay. So but Vs is less than E, but I tell you that this thyristor will continue to conduct till we get output current beta up to beta. So this output current will continue to flow in this direction, which will keep this thyristor turn on up to beta. So from pi minus theta to beta, this thyristor will continue to conduct. That's why we get drop across thyristor, that is equals to 0. Now output current equation will continue to remain same, that is that has been derived in previous slide. So we can see that from pi minus theta to beta also I naught is positive. And what is output voltage V naught when thyristor is conducting and it acts as short circuit? Then we get V naught is equals to source voltage Vs. So from pi minus theta to beta, output voltage appear, that is equals to source voltage. So this portion of waveform appear across this thyristor, this output. Okay. Now what is output power P naught? So here we can see that from pi minus theta to pi, V naught is positive, and from pi minus theta to beta, V naught is negative. That's why we can say, but I naught is positive from pi minus theta to beta. So we can say that from pi minus theta to pi, V naught is positive and I naught is positive. That's why P naught is positive. But from pi to beta, V naught is negative and I naught is positive. That's why we get P naught negative. So we will get both positive and negative powers from pi minus theta to beta. So inductor will dissipate its energy partially across resistance R's and partially energy is fed back to source. Now see the operation from beta to 2 pi. So from beta to 2 pi, we know that output current becomes 0 at angle beta. So when output current is becoming 0 and this anode to cathode voltage of thyristor is less than 0, that is negative, then thyristor goes into reverse blocking mode, because VAK is negative and current is also becomes 0, which is responsible for keeping this thyristor turn on has become 0. That's why thyristor goes into reverse blocking mode and it acts as short circuit. So act as open circuit. When thyristor get open circuited, then we get no current in this loop. That's why I naught is equals to 0. Output voltage V naught is equals to EMF E, because there is no drop across this inductance and resistance. And what is thyristor voltage? It is simply given by Vs minus E. And what is output power P naught? Output power P naught is equals to 0, because I naught is equals to 0. So this is all about this video. I hope you understand all the concepts, because these all concepts are repeated in my previous lectures. So we are repeating all the concepts. Okay, only the load changes and we change the modify the waveform according to the load. So all, if you know the concept, then drawing all these waveform is a cup of tea for you. So I hope you like this video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends, because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.